Hello and welcome back, and thanks for joining me on my little journey exploring the new Azure Synapse Analytics, putting it through its paces, seeing what it can do, can't do, how it compares to Databricks, and all of that kind of thing. One, apologies for the last video, I had the audio turned right down and hopefully that should be fixed. It's still echoey until I finish decorating, but we should be good. And I'm going to admit, I've had a little cheat. I was having to play over the weekend and just trying one or two things out. And I want to show you what I found, mainly comparing it to some standard training that I do with Delta. So I'm running a Databricks training course and I'm teaching people how Delta Lake works. Then there's a few things I normally run through just to show them how it works, and not all of that is compatible. Again, one of the big differences between Databricks Delta, the premium version you get in Databricks, and then the open source Delta Lake. So we'll have a look at a few of those things. Let's step over. Okay, right, so here's my little Databricks notebook, lots and lots of things in here, and let's have a step through and see what works. So firstly, you're just going to make sure that's all cleared up. Don't want that table there anymore, okay, so that's not there. And I've got a lake, and that normally has a folder called addresses, but I've deleted it. So we're starting blank slate, no data. Let's see what we can do. So we'll step in, and I'm just going to run this. So it's a base create table, giving it a schema, telling it I want to use Delta. So it's not got any data, there's no rows defined, there's no data frame here. But I'm just saying, this is a structure, register it with Hive, so I want it to be available for me to write SQL on it, use Delta, so it's going to have a transaction log, and then here's where to put it. Okay, so I should be able to now see that. So we go over to my lake. There we go, I've got addresses. And then I've got something in my trans log. So I've got my addresses with no data in it, and a Delta log with data in it. Blank slate, ready to go. Happy days. And then on the other side, in my data, I've now got my Delta database, and I can see addresses being registered. So that's kind of a two-in-one. Because I'm running in SQL mode here, I'm writing Spark SQL, then everything's going to happen within Hive anyway. So the entirety of this notebook, if I pop to the top, is written using SQL. So all of these commands, it's assuming it's SQL I'm writing anyway. Okay, right, let's get some data. So I've got a real straightforward insert into statement, just dummying up some data, having some random stuff, just I want to get some data in there so we can actually have a look at what it's doing. It goes, it does a couple of jobs. So it does one job to actually update the data, it does a second job to update the transaction log, and then we can go and run that just a couple of times. Now, big thing, this is super inefficient. Parquet is a column store storage type, so it's great for having large amounts of data, especially data that has repeated rows, repeated values. I think that little picture I had at the top kind of explains it. So if I've got a column of data and I've got A, B, C, the rows that have the same value, contiguous line of repeated values, it can squish up and go, well, actually, the next three are just A, and then I've got a B, and then I've got a run of three Cs, and that's called run length encoding. And that's one of the compressions that you see heavily in SQL column store, Parquet, all these kind of column store style things. Repeated values in a row, just slap them all down. A really, really good way of compressing. So we've got that. I've inserted three separate Parquet files. Because Parquet is compressed, I can't just add data into an existing Parquet file. So as we go over to our data and we need to hit refresh, I've got three separate Parquet files. Because each new insert, each separate batch of changes has to be a separate file. Not the best, but at least I've got some data. Okay, so I can then just do a quick select star, see what's going on, have a look at my data, and I'll see a little bit of info. Okay, I've got some basic data. And then if I was just given this without any info, if someone said, oh, there's a Delta table there for you, go nuts. Two commands. Firstly, just the straight describe. So if I'm inside SQL, very importantly, only SQL, not in the data frames. Describe is a very different function inside data frames. But if I'm in SQL, I run describe, I get the schema. Like, what is this thing? Here are the columns, here's the data types, I can start using it. Describe detail gives me the registration data. It says, well, actually, it's a Delta type, this is its full name, this is the lake it's sitting in. It tells me things like, this is how many files and the total size of bytes. Super useful information if you're trying to work out how efficient is it, how well compressed is it, all of that kind of stuff. So we've got those bits. So let's just try and do that over in Synapse and see how we're going. So firstly, just clear up my database if it's still there. This should give me an error because I've already deleted it. Okay, cool. Just saying no such object. That's already gone. So we can start. Before we do anything more in Synapse, I want to show you something quickly. Lots of people have had a little bit of confusion when they're first getting to grips. Mainly because inside the Spark pools, you can have a look at the Spark pool itself. And in config, it tells you a bit about current libraries. This is what's going on currently, this is what the tables look like, all of that stuff. And it's got Delta Lake version 0.4. I mentioned last time there's a big hoo-ha in build, and that's now 0.6. And then we're not seeing that reflected. We should be seeing version 1 for .NET for Apache Spark as well. But we don't get that. But that looks like that's just a refresh issue with that actual screen. It looks like it does have the later libraries actually installed. How can we tell? Well, we can question it. So I'm just going to switch over to Python mode for a minute. So if I do import Delta, so if I can spell, as let's just call it DT, and then I can just print out DT. Okay, so there we go. So I imported this library, so I brought it into context. Delta's pre-installed on that cluster. We don't have to worry about registering it or any of that kind of stuff. I can just say, bring Delta into context, tell me what that variable is, and it's like, oh, okay, well, that's a library. This is where it sits, and you can see 0.6. So if you're ever not sure, you're ever looking at that and going, well, what library is it actually using? Don't forget, you can just actually query it and say, what are you? Some Python libraries have that as a property, and you can go and query it that way, but easiest is if you just look at the actual thing, look at the file it's bringing in, you can usually tell what version it is. So pretty happy, it's 0.6, it's got all the new features of 0.6, so no issues there. Happy days. Right, okay, back to SQL land. So let's try and do what we're trying to do there. So we've got that create table, same stuff, using Delta. Here's my location. I've changed the location over because this is using the local lake to Synapse, not my separate data lake. And this is not going to work. So this throws up an error saying Delta does not allow user-specified schemas, which is a bit weird. And actually, it's more than that. So if I go back over to my lake and I grab so I've currently got addresses, and I get rid of that folder. So it's starting from the same place as earlier, completely from scratch, and I go create this thing. There's nothing there now. Go and create me a table. I get this going, right, it doesn't exist. It's expecting me to register a table that already exists. So if the folder's not there, it throws an error. And if the folder is there, but it doesn't have data or it doesn't have anything working, it still throws an error. It doesn't like the fact that inside this create table script, I'm trying to actually define the schema. So again, just not the full surface area of what you get inside Databricks Delta is implemented in Delta Lake. And that's just because Databricks haven't open sourced everything. They've got to keep something for themselves, right? So interesting to see what we can and can't do. So on the back of that, I did a little quick bit of PySpark. I need to tell it that this is PySpark. Okay, so just running that. Again, still getting used to the fact that I have to do 2 percentages, not 1 percentage as it is in Databricks, but it's fine. Okay, so that's created that. I'm going to write it down. So just get my data frame, write.format, save that in that location. That should happily go away. Oh, no, sorry, still Python. Let's do that again. I've been fairly lazy just switching between telling the whole notebook it's Python or SQL as opposed to individual cells. It all works. Okay, right, so that's going off, it's running that job. We should see what's going on. Now, the next bit of bad news. So that runs happily. At this point, it's not registered as a table, so I do need to kind of add that in as well. We can take that once that's finished. Succeeded, okay. So that's created my table. I've got my Delta table. So I should be able to see in my root directory, if I give this a refresh, got addresses, I've got some data, and I've got my Delta log. So we're at a similar state, except we had to do it in one step of creating data and creating the Delta at the same time, but that's fine. And then we want to register it. So I need to go back to my SQL script to register that table. So even though it's now a Delta table, it now exists, I still can't run this script. The script will still tell me off if I try and have those different bits and pieces in there. So again, can't use user-specified schemas. But I can strip that off now, like we did last time, and just say, there's already a Delta table sitting there. We've got credit. Oh, I need to create my database. It always helps when I clean things up too thoroughly. And it's just create database Delta. going to create that new logical database for me, create my table and register it, and then we're in the same place. So again, we can do all the same stuff. It's just the commands aren't exactly the same, and you have to occasionally take a couple of extra steps together. Okay, now this, our good friend. So we've got describe Delta address. So because we've now registered that Delta table with Hive, we can use the describe function, and there we go. I can see what my table actually looks like. Unfortunately, so if I do describe detail, it's obviously registered because it comes back and tells me that table's not supported in describe detail. Please use a path. It's like, okay, a little odd, but fine. So if I can go and grab that same path and just give it the same thing, and just say, do the same thing, go for my path, because we're in SQL land, I want single quotes. So I should be able to do that based on that message. Then from that I get execute error. And I think that's just a preview thing. I think that's just we've not implemented describe detail, and that's not working. So a little bit of warning, not everything's fully plumbed in then, not everything's fully working, but the core functionality of Delta's there. Okay, so let's have a look at some other stuff. I've got a quick example of what's going to be inside that transaction log. You'd see something like, this is when it was committed, this is who's committed it, so you can see how it's going and doing things. You can see if you did a update statement, that'll delete the old files and replace it with new files. You can do a merge statement, same thing. So you get this logical deletion and logical addition of files, and it'll give you some stats of how many records, minimum, maximum values, that kind of thing. So super useful. Now, Databricks Delta has this statement, it's called optimize, and that's one of the big things inside Databricks. Again, that's not going to be around in Delta Lake, the open source version. Now what that does is, for those 3 files that were created, where it's not very efficient, where it's, I've got lots of small, tiny inserts, it's going to look at those and go, well, that's not very efficient. Why don't you just have one file that has all 3 records in, and then you're going to get better compression. Okay, so it's looked at it, it's added a new file, and it's removed 3 files. So it's optimized to what the data is, oddly enough. And there's other things like Z-order that we'll look at another time. Now, interestingly, it doesn't actually go ahead and do any deletions. So if I go and look at my data, hit refresh, I can see my 4th Parquet file's been created. So I've got one that's a little tiny bit bigger than the others, because it's got 3 records as opposed to 1 individual record. But I can still see all 4 original files. And that's because Delta, it never actually physically deletes things until it knows you're done with them. The idea behind Delta being you kind of constantly are changing these files, replacing them, logically deleting the old files, and then you can do a thing called time travel. You can go back and say, I want to see what that looks like as of that date. And then in order to actually sort of do that kind of temporal query, it just ignores certain records in the transaction log and goes, well, actually, I don't need to worry about the files that this created. And these files I'm not going to treat as logically deleted because this transaction hasn't happened yet. Therefore, I read these Parquet files. And so it's only until you're kind of outside of that window you want to go and physically delete things. Now, that physical deletion happens by this vacuum command. So the 2 things that we're thinking about, optimize, that's not going to be available in Delta Lake. We're not going to be able to optimize things. But vacuum, we should be able to. So we can have a look at vacuum and see how that works. So let's switch over. Let's see what I can do. Have I got it ready? No. Okay, so let's just try and do, so if I do optimize, I can then put in delta addresses, hit go, and I should get a, what are you talking about? Just because that command's not a thing. It's weird that it comes up in IntelliSense. It kind of offers optimize as something that I might be able to do, and then goes, don't know what that is. And that's fine, that is a bit of premium functionality. Vacuum, however, should definitely work. So delta addresses, now that should go away, inspect it, and decide what to do. And then, again, table is not supported in vacuum. So again, it's expecting you to never use Hive for a lot of the maintenance tasks, which is just a little odd for me. It's expecting you to always go back to that path, always go back and work out where it is. Now, again, if I grab that path and say, don't use my Hive registry, use my path instead, it's going to go and have a look at the data, and it's running. To give you an idea of what that looks like on the other side. In this case, I can pointed at a Hive table, and there's a few commands you can use with vacuum. So you can say, well, how many hours do you want to retain? Am I deleting anything that was logically deleted from now, from a day ago, from 7 days ago, from 30 days ago? It depends on how long you want to keep that rolling history. Now, there is a check built in when it'll just tell you no if you try and delete anything that's too soon. So if I actually just try and run this as is, it's kind of got its kid gloves on and it'll go, no, you're not allowed to. Are you sure you want to vacuum? You're only using 0 hours. That's not long enough. So there's actually this little check that you can do. So spark.databricks.delta retention duration check is enabled. I'll say no, please turn it off. And then if we do that, it'll allow us to run a vacuum with a shorter amount of time than 7 days. And I've got this command called dry run. That means it's just going to tell us what it's going to do. Still tells us a little bit of info. We can see what it's doing. And it should say I've identified 3 files, because we did optimize, therefore we've got 1 file that supersedes those 3. Identify those 3 files, it says it's going to delete them. And so if I actually run the vacuum, that'll go through, identify those 3 files again, and delete them away. So that's nice, that should work. And then if we switch back to Synapse, we can see what's going on. So there we go, so that's still in progress, running its vacuum. It's doing a lot of things for a table which I only created with barely anything in. But I think what I've noticed with Synapse is it just tends to report a lot more than normal Databricks does. Because every time you run a query, it kind of gives you a couple of jobs which seem to be telling you it's going through the optimization engine and deciding what to do at the Spark context rather than just the actual Spark jobs that are needed. So you always seem to get a little bit of extra info whenever you're in Synapse. It's going away, thinking about things, doing lots and lots of things, even though I only had 2 rows in that table. And it's still running its last one. So I switch over. So this is now completed. So that's gone off, did this thing. So in our Databricks side, so we originally had these 4 Parquet, we ran a vacuum, and we now got 1 Parquet. And we still got all our transactions. So it still knows, we'll still have the history of I created these tables, I added these Parquet files, I deleted these Parquet files. We ran a vacuum which has actually deleted these. They're all nicely kept. But we no longer have the data. So if we tried to do a temporal query, we wouldn't be able to do that. Okay, so Synapse is still doing lots of things. No idea what it's actually doing. But eventually we should actually see it's vacuumed. It seems like one of those things it's not fully properly implemented yet. Certainly to vacuum 2 Parquet files shouldn't take that long. Unfortunately, as I've been going around trying to play with things, I've got the Open Spark UI button. And that seems to be a very unhappy bunny currently. Anytime I've tried, it's given me a Active Directory token error, which is always lovely. So let's see if this is behaving anymore. But for now, I can't get in there. Brilliant. First time I've actually been able to get into the Spark UI, so we can see what it's actually doing, which is great. Okay, so it's kicking off job groups. So there's a single statement, and that's kicked off so many different jobs. Again, over in Databricks to do that. So to do a vacuum, we had 2 steps, which I'm assuming was one to actually do the vacuum and work out what it should do, the other one to actually delete the files. Whereas now we're having all these different things with so many different stages. I don't know how to dig in and kind of try and see if we can figure out what's going on under the hood here. But that's looking fairly inefficient. That's looking like it's doing a lot more than it really should be. But I'll report back when I've figured out what's actually happening. But yeah, so that's the first things I wanted to show you about Delta. So remember, Delta is awesome in that it's doing this kind of thing under the hood. It's kind of giving you that way of doing traditional SQL, right? I can do insert, update, I can do merge, all in SQL or in data frames. And then normally with Parquet files, you'd have to write a load of stuff to get it to manage that for you. Now, I can just register those tables, write a bit of SQL. It'll do things fairly efficiently under the hood, but then certainly in Databricks, we've got the optimized command to sort that out, to tidy up and make it a little bit nicer to work with. In Delta, like we'd have to write something manually to say, pick up these files, put them back down again, and have regular things, kind of regular job we just run at the weekend, kind of just to say, sort out my table, read from here, put it back down over the top with an overwrite, use this partitioning, that kind of thing. So it's okay. Certainly we know that's a limitation with Delta Lake when it's open source anyway. But at least lots of commands are there, lots of things are actually working, not everything's fully implemented there yet. So I'll keep exploring, I'll keep reporting back in terms of what I find. But yeah, hopefully you guys can get in, have a play, let me know what things you're struggling with, let me know what's good and what's bad. But certainly next time, having a look a bit more into time travel. So I'll show you how we do versioning, how we can do an update, and then say, well, what was that before the update and after the update and how that changes. And my little investigation, that all looks really, really solid in Synapse so far, so should be good. Yeah, hope you join me next time. Cheers.